Okay, so let's look at number 27, which is asking about partial sums of infinite series. And the most basic way you tell if an infinite series converges or diverges is by looking, it's like you make up a new sequence of numbers to examine. And it's the sums as you add each new term. So like this one right here, the first sum that you get is when you only have the first term. So that would be -2. And then the second sum you get is when you add up a1 and a2. So that would be these two terms, and then you get 0. Well, let me write it out. It'd be -2 plus 2, which is 0. And then the third one you get is when you take these three terms. So it's a1 plus a2 plus a3, and then you get -2 plus 2 minus 2, which is back to -2. If you go to S4 and add up the first four terms, you get 0. If you add up the first five terms, you get -2, and it just keeps going like that. And so what you want to examine is the sequence of partial sums. Oh, actually, it says the first six partial sums, so the sixth partial sum would be 0 again. So if you actually look at the sequence of sums, it goes like this: -2, 0, -2, 0, -2, 0, ... So if we examine what happens as n goes to infinity for the sums, because really the goal is, well, what's the biggest sum that we could get? Or the sum of all the terms. And really so we're examining a sequence at this point, and we know that if that sequence doesn't converge, then the series itself doesn't converge. So this one does not exist because it doesn't zone in on one single finite number. It zones in on two. So since it doesn't zone in on one, it does not exist. So the series itself is divergent. Let's look at B over here. So the very first sum that you get is when you just take the first term, and that's 1. The second sum is when you do 1 minus 0.7. You take the first two terms, you get a 0.3. The third sum, 1 minus 0.7 minus 0.07, gives you 0.23. The fourth sum, 1 minus 0.7 minus 0.07 minus 0.007, that gives you the value 0.233. Or sorry, 0.223. The fifth sum, if you work that out, actually gives you 0.2223. And the sixth sum gives you 0.22223. So you can probably guess that the nth sum will give you something related. And if you look at what happens as n goes to infinity for all those sums, for the, when you add up all of the terms, you end up with this value, 0.2 repeating. And there'd be a 3 stuck all the way at the end, but since it goes out to infinity, you never get to the 3. Well, that's the same thing as 2/9 right there. Okay, hope that helps. Oh, yeah, sorry, one other thing. So then you would say the series converges to 2/9.